today we start chapter 2. So what I have right here for you guys is some of the learning targets associated with this chapter. These are the first learning targets that we're covering that are actually part of the curriculum for IB, HL, and SL. So I wanted to make sure that you saw exactly what these things were and how they would be assessed. We can look at later with DP style questions, but do be aware that these are the targets for this unit. And our sub-goals that we look at each video give us an opportunity of what specifically we're drilling down. But these are the big learning targets for this chapter. So today we're going to look at what the concept of a function is, and then graphing functions. You should be really comfortable with most of this material. But I did want to take a few minutes to review what's covered here in 2.1. So functions versus relations, this goes back to that idea of like, is it a root vegetable or is it a carrot? Because carrots are root vegetables, right? But not all root vegetables are carrots. So that's what I like to think about when I think about relations and functions. All functions are technically relations, okay? But not all relations are functions. So a relation is any set of ordered pairs that can help us to identify what we're looking at. Is it a relation? Well, is it a set of ordered pairs? Sure. Yes, it's a relation. Is it a relation? Set of ordered pairs? Absolutely. Is it a relation? Set of ordered pairs? Check. Mapping is just a visual way of looking at the comparison between the inputs and the outputs. And you can see this is also a set of ordered pairs. So these are all relations. But is it a function? That's the question. Well, we can use our one-to-one test. So for every input of x, is there only one y? It's okay to have one y that meets with two different x's, but it's not okay for an x to have two y's. That's why the vertical line test can be a helpful tool for us in determining functions. So this is a function. We don't have any repeats over here in this column, so that means that every single x matches with a different y. So I don't have any x's repeated with different y's. So also a function. Okay. Here's our set of ordered pairs. Do I have any repeats of y with a different x? Nope. Also a function. And then this one can be kind of hard to understand since we've never looked at it before, but a mapping can be a great tool because it shows that for this x right here, it only goes to one y. This x goes to the same y, but that's okay, right? Like here, this x goes to 10, so does this x. That's okay. However, if one of these x's had two arrows coming from it to different y's, that would be a big like red flag to tell us that this is not a function. So that isn't occurring. Every x has a different y, right? Or every x has one y, so it must be a function. We're going to look briefly here at domain and range and how to note that in set notation. So here I have a rational function with a vertical asymptote. They all have vertical asymptotes, and a horizontal asymptote. So this has a horizontal asymptote along the line y equals 0 and a vertical asymptote along the line x equals 2. There, I finished my number for you. So we can write this in set notation. So you can say it this way, x such that x is an element of the real number system, but x cannot equal 2. So that's one way we could do it. The other way we could do it is to say that x is an element from negative infinity, not included, up to 2, not included, with a union of the set 2 not included up to positive infinity. So these both are telling you the same thing, that x can be anything except for 2. Y's done the same thing here, only they're indicating that y cannot be 0. If you want to practice, you can check like y equals 1 over x plus 3 or something like that. You can practice graphing and then practice writing the domain and range. Okay. Here we're looking at function notation. So we have f parenthesis x close parenthesis, f of x equals x squared. So the function f in terms of x is x squared. F of x equals x squared. Okay. F of x maps to x squared. So it's also a different way of talking about f of x, the function in terms of x. And then we have f of 3 equals 9. So we're talking about a specific value of x. When x is 3, the output is 9. And then when we are looking at 3 as our input, it maps to 9. So thinking back to our circle mapping on the last page, 3 would map to 9. So let's quickly check if these would be a relation or a function. So visually, we can use that vertical line test. Yep, all looks good. Function. Here, we can see that along this line right there, if you were to draw that, value of x right there has multiple values of y. So this is a relation, not a function. This is a relation too, but because it's a function, that function trumps what we're going to categorize it as. Algebraically, we can recognize things to be functions or not based upon kind of what we're looking at here. So this one is the equation of a circle. Circles are never functions. So this is a relation. This one right here, y squared equals x. So if I were going to square root both sides, I would see that I got a plus or minus here, so 2 outputs. So unless you do domain restrictions on this function, it's also a relation. Unless domain restrictions. Okay, think back to this one. This is the inverse of sine. So if I graph sine, and I took the inverse of it, remember the horizontal line test? Its inverse is not a function. So this is a relation unless you have domain restrictions.